Right, so welcome back. Today we are going to do basics of trigonometric functions. First, we are going to do very basic trigonometry. Like most of the things will be things that you have already learned before. Okay, so I'll do it very fast. Now, first we are going to study angles. So now, if I look at a Cartesian plane, okay, if I have a x and y axis like this, and then say I draw a line. Okay, if I draw this line here. Now, I ask you a question. What is the angle subtended? Subtended means like the angle that is created by the black line. Okay, I ask you the question. So, when I ask this question, what I mean is the angle that is formed by that black line with respect to this part of the axis. So it's always the right part of the x-axis. Okay, the right half. Okay, this part. Alright. So what I want to know is, I want to know this angle here. Okay, that is the angle I want to know. And which direction am I going in? Notice the arrow. This is called a positive angle. And which direction? This is counterclockwise or anti-clockwise. Okay, which is opposite to the direction of the clock. Okay, lawan arah jam. So that is one way. But there is another way I can get the angle. And that is if I go the opposite direction. Right? So this is what we call the negative angle. And this is clockwise. Okay, meaning this one ikut arah jam lah. Okay? This is the negative angle. Together they form a circle. See, notice? Together the black line, the black angle and the maroon angle both will form a circle. And what is the total angle of a circle? It is 360 degrees. So angle of a circle may be like this, right? This is angle of like full angle is, okay, we know this. Now, so there are two angles subtended by the black line. One is the positive angle, one is the negative angle. And of course, like the name suggests, the positive angle, the number will be positive, negative angle, number will be negative. Alright, so let's do an example. Say this is my line. Okay, and I give you one angle, so maybe I give you this one. Okay, so what angle is this called? This is called the positive angle, right? Because it is going this way, counterclockwise. Say I give you this one and I say it's 200 degrees. Okay, now I'm asking you find this angle. Okay, so this is a question mark. Find that angle. How will you do? That is the negative angle, right? First, a negative angle is negative, so this negative sign must be there. Okay, and then I'm going to do a calculation. What is the calculation? How are you going to find this green color angle? What did we say? We said that a full round will be 360, right? So a full round is 360, and this purple, oops, sorry. Now this part here is 200. So what is the remaining? What is this baki here? That should be 360 minus 200, right? That will give you this green angle here. Okay, and that is, so what is this angle? This is negative 160. Okay, so the step is simple. If they give you one angle, so here we gave the positive angle and I asked you to find the negative one. If they give you the negative angle and then ask to find the positive one, same. You take 360 minus the actual value of that angle, the size of the angle, okay, so that you get the remaining. And then if it is negative, you put a negative sign here. If they ask you to find a positive, you don't have to. Alright? Okay, so we can do some exercises later, but I don't want to spend too much time. Okay, nice. Now we will talk about basic trigonometric functions. Again, I think by the time you finish Form 3, you already finish all of this. Okay, for the current Form 5 students, you finish this exactly in Form 3. So, say I give you an angle. So this is, well, what triangle is this called? So this is called a right angle triangle because it has a right angle. This is the 90 degrees angle. Okay, so let's say I give you this angle and call this alpha. Okay, now we know that this, what is the name of the longest line in a right angle triangle? There's a special name for this line. It's called the hypotenuse. Okay, and then since our angle A is here, the line that is near the angle is called the adjacent, and the other line is called the opposite. Okay, so for simplicity, okay, nak bagi senang, let me use letters. So this is just H, A, and O. Okay, my angle is alpha. Nice. So, can anyone remember what sine of alpha is? So sine of alpha is just the opposite over the opposite over the hypotenuse. So this is O over H. Okay, nice. Cosine. So what's a cosine? The definition of cosine is adjacent over the hypotenuse. And the definition of tangent is opposite over adjacent. Okay, you can also write this as, if you divide the numerator and denominator by h, okay, it doesn't change anything. Okay, I'm dividing both the atas and bawah, okay, both top and bottom with h, and then what I get is the top becomes sine alpha, bottom is cos alpha. So tangent is also sine over cosine. Okay, cool. Now, so let me just take out one step here, and then just to make it easier for you to read. Okay, cool. Now I'm going to give you three more. So not just sine, cosine, and tangent, but now there is also cosecant, secant, and cotangent. Alright, so cosecant is 1 over sine, secant is 1 over, it's okay. So cosecant is 1 over sine, this is 1 over O over H, which is H over O. Okay, so secant is 1 over cos or cosine, and this will become H over A because cosine is A over H. Similarly, cotangent is 1 over tangent, and this is A over O. Alright, so now we have these three extra ratios or functions. Dulu we only used to have sine, cosine and tangent. Now I'm adding another 3. Most important is that you remember the definition, meaning all these definitions: 1 over sine, 1 over cos and 1 over tan. Okay, that is the definition of cosecant, secant and cotangent. Okay, nice. Now I've drawn two circles here. Two triangles here. They are very important triangles. So first one I want you to think about, it's not exactly correct. I cannot draw a very accurate triangle, but this is supposed to be equilateral triangle, and the second is supposed to be isosceles. Okay, so in the first triangle I want to make my lines each side 2 centimeters, and then cut the triangle into half, so this becomes 1 centimeter and 1 centimeter. Okay, and then since the triangle has equal sides, the angles must be equal, so this thing must be 60 degrees, this also 60 degrees, and this whole thing is also 60 degrees. But I don't want to do it that way. I want to separate the angle. This is 30 degrees, this is also 30 degrees. Okay, so now one last question for this triangle. What is the length of this line? So if you remember the Pythagoras theorem, okay, you know that this line has a length of square root of the hypotenuse, which is 2 squared, minus 1 squared. This is 3, square root of 3, because if you have a triangle like this, ABC, then a squared plus b squared equals to c squared. So now we are trying to find b, right? So b squared equals to c squared minus a squared. So b is equal to square root of c squared minus minus a squared. Okay, let me see. Alright, so that is what we are doing here. Okay, cool. So I erase all of this. I cannot erase very clearly this thing. Okay, so this is square root of 3, that is the height. Okay, and this is a right angle. So remember, we have this triangle here which is 60, 30 and 90, and then this length is 2, this length is 1, this one is square root of 3. Alright, for the second triangle, the isosceles triangle, okay, this is isosceles. So for this triangle, I want you to make this length 1 and this length 1. So isosceles means two of the lengths must be the same. So now I make this length and these two lengths the same, and so my angle is 90 degrees, and how many more degrees I have to play around with, because one triangle means must have 180. I already used 90, so I have 90 left. If I divide half, 45 and 45. Okay, and again by the Pythagoras theorem, this should be 1 squared plus 1 squared, right? This is the hypotenuse, right? So this is square root of 2. Alright, so now we are done with this, Now I want to ask some questions. Can anyone tell me what sine of 60 is from this first diagram? So this is 60 degrees. So where's the opposite? Opposite is square root of 3. The hypotenuse is 2. So the sine is square root of 3 over 2. Sine of 30. Oh, oops, sorry. Let's do cosine. Cosine of 60. So same angle. Where's the adjacent? Adjacent is 1. Hypotenuse is still 2. So this is 1 over 2. And then the tangent of 60 is opposite over adjacent. Meaning, which is the opposite? The opposite is square root of 3. The adjacent is 1. So this is square root of 3 over 1. Or you can just write square root of 3. So if you do this, you can do this for 30, you can do this for 45. Alright? So when you do it for all these angles, this is what you get. Okay? I hope you can remember this. If you can remember these 9, it will be good. These are the special angles. Okay, we call them special angles because it's easy if you can remember all of this. So this is important. I might say try to remember. Okay, so you can always get this from these two images. So if you forget anytime, just go back to the images, draw the images, and then you can get back the answers. Okay, if you forget, say what is tangent of 45? Oh, if I draw this triangle back, I can get, okay, tangent of 45 is, what is tangent? The opposite over adjacent. So it's 1 over 1, it is 1. And then check back. See, tangent of 45 is 1. Alright, so I'll see you in the next video. Until then, stay safe. Thank you. Goodbye.